Okay, so what would be the equilibrium temperature of the planet in space if there were no greenhouse effect? Okay. Okay, so this is sort of interesting, right? So let's picture this. Here's our planet, right? And we know that it absorbs energy from the sun. From these previous problems, we know that it absorbs at 116.669 watts for every square meter on the average, right? Right, so what would be the average equilibrium temperature? I guess we need to add that word to it, right? Okay, well, that means that the radiative heat transfer has to be 116.669 watts per square meter out, right? So how do we get watts per square meter from this formula? Radiative heat transfer has an area in it, right? It's E sigma area temperature to the fourth. Well, let me show you how you do this, right? Intensity is just power over area, right? So let's divide this by area. Hey, that's fun. That's fun, isn't that fun? Okay, so the areas just cancel out, right? And so the intensity equals power over area, and that's just equal to E sigma temperature to the fourth. Okay, how do they expect you to know this? Well, that's why I made these videos, right? I'm seeing these questions on the test. They think you ought to be able to do this. All right, so let's take a look at this, right? We know that this is our intensity. It needs to radiate that intensity, so let's figure this out. So 116.669 equals, and then it's like, what do we use for the emissivity? If they don't give you one, just use 1. Okay, so 1 times sigma 0.67 times 10 to the minus 8th. And this is, anyway. And then t to the fourth, right? So now we can do maths, right? We can do maths. So what am I going to do? I'm going to take this, divide by this. Divide by 5.67 e to the minus 8th. Boom. And now I've got what t to the fourth is, so I just raise that number to the 0.25. And I get 212.98. Kelvins, right? Okay. Now, on the test that I took these questions from, they did the questions for Earth. On the test, they said the next question was, the temperature of the Earth is considerably higher than this. Explain this in terms of the greenhouse gases, right? Well, remember that energy is going to radiate out, and the atmosphere absorbs some of it, right? This is going to be pretty long wave infrared, but if the atmosphere has carbon dioxide in it or methane, it will absorb that and re-radiate some of the heat back to the Earth, so it won't all be lost. That's kind of fun. So it'll be a higher temperature. Okay, that's what's going on.